So far in our previous session we had learned how to name the coordination complexes following the IUPAC rules. Now let us see how the formulas of mononuclear coordination entities can be written. The following are the rules to be applied while writing the chemical formulas. Always the central atom is to be listed first, followed by the ligands in alphabetical order. Polydentate ligands are also listed alphabetically. In case of abbreviated ligands, the first letter of the abbreviation is used to determine the position of the ligand in the alphabetical order. The formula of the entire coordination entity, whether charged or not, it is enclosed in square brackets. When the ligands are polyatomic, their formulas are enclosed in parentheses. Ligand abbreviations are also enclosed in parentheses. There should be no space between ligands and the metal ion within the coordination sphere. When the formula of a charged coordination entity is to be written without that of counter ion, the charge is indicated outside the square brackets as a right superscript with the number before the sign. For example, in this coordination entity, it is an anionic complex and it carries a charge 3 minus. So, you can see here COCN taken 6 times enclosed in the parenthesis. We are writing 3 minus, the charge of the complex ion, at the right top corner as a superscript. Similarly, even in case of Cr, H2O taken 6 times, 3 plus also, we have indicated the cationic charge as the right superscript. The charge of the cations is balanced by the charge of the anions. After completing writing the formula of the complex ion and the counter ion, we have to see that the charges are balanced. Now let us see some examples and try to name the complex, write the formula of the complexes. First, we will take tetramine diaqua cobalt 3 chloride. In this complex, central metal ion is cobalt. So, we will begin with the formula by writing CO inside the parenthesis, followed by the complex ligands present. There are 2 types of ligands present, amine and aqua. Amine is NH3, aqua is water, and we can see with the numerical prefixes indicated, we understand that there are 4 ammonia molecules and 2 water molecules. So, we will write the formula as CO, NH3 taken 4 times. Why we have written ammonia first? Because we have to follow the alphabetical order. So, NH3 taken 4 times, followed by C. So, the formula of the complex ion is CO, NH3 taken twice, H2O taken twice, enclosed in parenthesis, and the charge on the complex ion is 3 plus, because here it is indicated in the name of the complex that cobalt exhibits an oxidation state of 3, and moreover the ligands present, ammonia and water molecules, are neutral ligands. So, the charge on the complex ion is equal to 3 plus, and the counter ion present is chloride. To complete writing the formula, see that the charges of the complex ion and the counter ion are balanced. So, write Cl3 to balance the charge. With this we complete writing chemical formula of this compound. Now, let us see the next compound, potassium tetracyanidonicolate 2. In this complex, the cation present is potassium and it is the counter ion. Always the positively charged ion is to be written first. So, write K potassium, K plus you can write. Then write the formula of the complex ion. The complex ion will start with parenthesis and identify the central metal ion. It is nickel, followed by the ligand is cyanido, it is Cn, And how many times the cyanide ligand is repeated? It is 4 times, and it is the only ligand. Therefore, NiCN taken 4 times. Now, close the bracket, and now we have written the formulas, the symbols of the cation and anionic complexes. Now, appropriately in class 9th you had learned how to write the formula of a compound. Following those rules, cross multiply the charge and then write the final formula of the compound in order to balance the charges on the cation and the complex ion. So, the formula of the complex ion becomes, because nickel here has +2 charge and cyanide has -4 charge, the charge on the complex ion is 2 minus. So, to balance the charge, it is K2 NiCN taken of the second complex. Now, let us go to the third complex, tris ethane 1,2-diamine chromium 3 chloride. Chromium 3 chloride. Here in this case you can see the central metal ion is chromium and the ligands present are ethane 1,2-diamine. Only one type of ligand is present, that is ethane 1,2-diamine. And how many times it is repeated? The prefix tells it is 3 times, tris. So, it is 3 times. So, start writing the formula. Parenthesis, central metal ion chromium, Cr, the ligands present En, enclose them in a bracket, indicate how many times the ligand is repeated, it is 3 times tris, enclose it in a parenthesis. Then what is the charge on the complex ion? It is 3 plus. So, the formula of the complex is Cr En taken thrice, Cl3. Now, let us see the next complex, amine bromido chlorido nitrito N platinate 2. In this complex, platinum is the central metal ion and the ligands present are amine bromido chlorido and nitrito N. So, the first ligand present is amine, so NH3. So, write the parenthesis, platinum the central metal ion followed by the first ligand NH3, and only once one ligand is present, so NH3. Then the next ligand present is bromido Br followed by chlorido Cl, then nitrito, that means NO2 group is present and it is indicated as nitrito N. It means that the attachment of the ligand is through nitrogen atom, because NO2 is a ambidentate ligand. So, it can attach either through oxygen or nitrogen. Here it is indicated through N, capital N indicates that the attachment of the ligand is through nitrogen atom. So, nitrito N. So, NO2, enclose everything in the parenthesis, that gives the formula of this complex. And the next compound is dichlorido bis ethane 1,2-diamine platinum 4 nitrate. Dichlorido bis ethane 1,2-diamine platinum 4 nitrate is the name of the complex. Then how to write the formula? First, identify the central metal ion, it is platinum. Identify the ligands present, ethane 1,2-diamine and chlorido, both are present. What is to be done next? Arrange these two ligands in the alphabetical order. So, chlorido comes first in the alphabetical listing. So, name indicate the symbol of chlorido ligand first, and it is dichlorido. So, and it is bis ethane 1,2-diamine. So, two ligands of ethane 1,2-diamine are present. So, En taken twice, and remember such polydentate ligands are indicated in a bracket, okay, enclose them in a parenthesis followed by 2. And Now close the bracket and followed by the counter ion. Counter ion is nitrate. Now see that the charge on the complex ion and the counter ion are balanced by suitably multiplying with a suitable number. Then finally the complex formula is PtCl2 En taken twice, NO3 taken twice is the formula of the complex. Next complex is iron hexacyanide 2. Here there are two iron atoms, the central atom and also the counter ion are iron atoms. In case of the counter ion, the iron atom is in +3 oxidation state, while the central metal ion is in +2 oxidation state. Now let us begin writing. First write the central metal ion Fe, it is in +2 oxidation state. Enclose it in a parenthesis first, begin the parenthesis and write Fe. Then we have hexacyanide, 6 cyanide groups, so write Cn subscript 6 indicating 6 cyanide groups, enclose in a parenthesis. Find out the charge on the complex ion. It is equal to 3 minus. Then cross multiply the charge on the counter ion and the complex ion to get the formula of the compound. It is Fe3 Cn it is Fe3 Fe Cn taken 6 times whole multiplied by 3.